Here is the 2025 Additional Mathematics, Paper 1, Question 8, under Calculus. And the question reads, given that y is equal to x, open brackets, 2x plus 1, close brackets, to the power 4, find dy dx. And question B reads, find the equation of the normal to the curve y is equals to 5 over x plus 1 at the point where x is equal to -2. So in the first question, we have been told to find dy dx of this function. So in short, they just want us to differentiate this. And then on part B, they just want us to find the equation to the normal at the point where x is equal to -2. So follow attentively so that you don't miss any step. Okay, so we have our solution. Okay, solution down here. So let's begin by answering question 1. Okay, so of this equation, y is equal to x, open brackets, 2x plus 1 to the power 4, and you have been told to find the dy dx of this function. So how can we differentiate this? So we can differentiate this using the product rule, and the product rule under calculus states that v dy dx is equal to u dv plus v du, okay, dx. Okay, this is how the product rule is, u dv plus v du. So we can simplify this as u dv plus v du. So this means that you multiply the u that you have, which is it's this one, the u it's this one, and then your v it's this one. So you multiply the u, which is this one, by the differentiation of your v here. Okay, so our data here, so that we don't get confused, our data. So we have two parts here of x, and we also have 2x plus 1 to the power 4. So we can name each one of these as our v or our u. So let's say we get this as our v. So we're going to have a v is equals to x, and u is equals to, we get the one that has remained, which is 2x plus 1 to the power 4. So we're going to have 2x plus 1 to the power 4. Okay, so this is our data of our v, it's x, our u it's 2x plus 1 is equals to 4. Then you find the differentiation of our v, also find the differentiation of our u, so that we can just replace in this formula of ours. So here where it says dv, it means that you multiply u by the differentiation of the v. Even here you multiply v by the differentiation of our c. So here let's differentiate our v. So okay, so you can write dv dx as this one. This writing as dv dx is the same as writing like this. So is equal to, what is the differentiation of x? So x has a power of 1. So we're going to do 1 multiplied by this. So we're going to have 1x, and then this power we must subtract by 1, and so we're going to have 1x to the power 0, and this will give us 1. Any number to the power 0, it's 1. So here we're going to have 1. Okay, let's now find our u. Okay, our u dv. So if you have a situation like this, a situation like we can write it to here. Okay, a situation like 2x plus 1, sorry, 2x plus 1 to the power 4. So this 2x plus 1 to the power 4, this can be differentiated as you do 4 multiplied by this. So we're going to have 4, then you open brackets, you just put this inside 2x plus 1. Then the power, you subtract 1 from the power. So we're going to 4 minus 1, it will give us 3. Then you multiply this, the whole this by the differentiation of this one which is inside, this one which is inside. So 2x plus 1, if you differentiate 2x plus 1, you're going to find that the answer is 2. The answer is 2. Okay, like this. Then you just multiply 2 by this. So we're going to have 8, open brackets, 2x plus 1 to the power 3. So this is the differentiation of this. If you differentiate this, you're going to obtain this. Okay, so our u can write that we found 8, open brackets, 2x plus 1 to the power 3. Okay, so if you're watching this on TikTok, give it a follow and a like, and if it's on YouTube, please subscribe. So having done this, you just now replace in your formula here. You just now replace in your formula. So we have our formula u dv. So u, what's our u? Our u it's 2x plus 1 to the power 4. So we're going to have 2x plus 1 to the power 4 multiplied by our dv. Our dv meaning the differentiation of v, we found that it's 1. So here we're going to have 1 plus, okay, plus here our v it's which one? Our v it's x, right? X multiplied by our du simply means the differentiation of our u, which is 8, open brackets, 2x plus 1 to the power 3. So we're going to have 8. So this we can put it like this, okay, like this, so that we don't get confused. 2x plus 1 to the power 3. Okay, like this. So this x multiply can be multiplied with 8. So we're going to have a situation 2x plus 1 to the power 4. 1 multiplied by this won't change, plus x multiplied by this, we're going to have 8x. Okay, 8x, open brackets, 2x plus 1 to the power 3 to the power 3. So this is the divide x of this one. This is the divide x of this one, and this has 3 marks. Okay, let's now proceed to the second question, which reads, find the equation of the normal to the curve. So sorry for this. Find the equation of the normal to the curve y is equals to 5 over x plus 1 at the point where x is equals to -2. So we're finding the equation to the normal at a point where x is equals to -2. So this is the curve that we have. So you get your curve y is equal to 5 over x plus 1. So we're finding the equation to the normal at a point where x is -2, where x is equals to -2. So for you to find the equation, you need to have a coordinate, and coordinates are written in the form of x, y. So we have our value for x, which is -2, but we don't have for y. So this means that we should find our y. We need to find our y. So for us to find our y, we just need to replace this value of x in this equation. So we're going to have y is equal to 5, where there's x, we replace with this. We're going to have -2 plus 1, hence y is equal to 5 over -1. 5 over -1. So 5 divided -1, this will give us -5, -5. So this is our coordinates. So we have coordinates -2, -5. -2, -5, this is our coordinates. So having found our coordinates, you now find the gradient, because the gradient is needed for us to find the equation. So since you have been given the curve y is equals to 5 over x plus 1, so the differentiation of this one, it's that's our gradient, the differentiation of this one, that's our gradient. So let's just differentiate this. So we have y is equal to 5 multiplied by x plus 1 to the power negative 5. So this can be also written in this form. It can be also written in this form because this simply means that 5 times, when you have a power of negative, it means that 1 over x plus 1 to the power 1. Hence, it will bring you to this stage. Okay, so let's now differentiate this one. So this can be differentiated easily. You just do negative multiplied by this. You're going to have, or the power multiplied by this. So we're going to have negative 5, open bracket x plus 1. Then you just multiply by the differentiation of this one, which is inside. So multiply by. So if you differentiate x plus 1, we're going to have 1. Okay, so then you just multiply. So negative 5 x plus 1. So this is our gradient. So since you know the value of x, which is negative 2, just replace in this gradient that you have to find the gradient, the original gradient. So negative 5, where there's x, we put this. So we're going to have negative 2 plus 1. Okay, and this will give us negative 5 minus 1. Before here, when you differentiate this multiplied by this power is subtracted by 1. So we're going to have 1 minus 1, and this will give us negative 2. So here we have a power of negative 2, also have a power of negative 2. So negative 1 to the power negative 2, this will give us 1. This will give us 1. So we're going to have negative 5 times 1, and this will give us negative 5. So our gradient is negative 5, but remember we're finding the equation to the normal. So the gradient of the normal, it's perpendicular. So you do m1 times m2 is equal to negative 1. m1 multiplied by m2 is equal to negative 1. Okay, so this is our m1. So we're going to have negative 5 times m2 is equal to negative 5. Then we just divide both sides by negative 5 so that we remain with our m. So negative 1 divide negative 5, it's 1 over 5. This will go. So m2 is equal to 1 over 5. Okay, then you just find your equation. So of the coordinates, we found negative 2 for x, and for y we found negative 5. Okay, you can now find the equation easily. You can now find the equation easily using the formula y1 minus y is equal to m x1 minus x, or y is equals to m x plus c. You have your gradient, you have the coordinates. So I believe from now you can find the equation. So if you're watching this on TikTok, give it a follow, and if it's on YouTube, please subscribe to the YouTube channel so that you get notified when you solve another question. Our aim is to solve all the ECZ questions that have come either in additional mathematics, science, chemistry, biology, or the subjects. I greet you.